So continuing off the previous video, for number 3, let's find the volume of the region bounded by y equals x squared, x equals 2, and the x-axis. And this time we're going to rotate the region about the line x equals 2. So if I were to draw a quick sketch of this, we'd have y equals x squared, x equals 2, and the x-axis. So the shaded region, or the region being bounded by those graphs, is the region that we're going to rotate about the line x equals 2. So we're going to rotate that region around this line. Now I'm going to write the formula once again. So the volume is equal to pi times the integral from a to b of r of y squared dy. And the reason why it's r of y is because we're actually rotating around a vertical axis, like the y, similar to the y-axis. When we rotate around a horizontal axis, or the x-axis, then we're going to put everything in terms of x. But this time we're doing it around a vertical axis, so we need to put everything in terms of y. So the very first thing I can do is find out my a and b values, or in other words, the y bounds. So from what y values is the region being shaded from? And we know it starts at y equals 0. So my a value is going to be 0. And we need to know what this y value is. So notice how those two lines intersect right at that y value. So we just need to set them equal to each other to find that intersection point. So we got the line x equals 2, which is this one. And we got y equals x squared. And before we set them equal to each other, notice how x equals 2 has it in the form of x equals something. So we also need to change y equals x squared so that we can isolate x and say x equals something in terms of y. So if I were to rewrite y equals x squared, I can take the square root to get rid of the square, and I'll get the square root of y equals x, or x equals the square root of y. So now I can say that the square root of y is going to be equal to 2. And then I can square both sides, and I'll get that y is equal to 4. So at y equals 4, that's where those two lines intersect. So now that we know our bounds, we can rewrite the volume formula. So we get pi times the integral. We're going from 0 to 4 of r of y squared dy. So I'm just going to draw another graph, just a close-up look of the region that's being shaded. So we have this line here, which is x equals 2. Just put it down here. And then we have this function, which is y equals x squared, or since we're putting everything in terms of y, I'll put x equals the square root of y. So notice how we're not rotating around the y-axis. This time we're going to do it around the line x equals 2. So that is our axis of revolution. So when I write my volume equation, so we get volume equals pi times the integral, we're going from 0 to 4 obviously, of r of y squared. So we need to find what r of y equals. So notice how we're going to go from the axis of revolution to the outside function. And the outside function is x equals the square root of y. But since we're rotating around another axis other than the x or y axis, we have to put the axis of rotation, so 2, x equals 2. So we'll put 2, and we'll put minus the function. So whenever we're rotating around something other than the y or x or y axis, we're always going to have to put the axis of rotation, so in this case x equals 2, the axis of rotation minus the function. So minus the function, which is equal to the square root of y. So I'll put 2 minus the square root of y, and we're going to take that squared, because r of y is squared, dy. And this is what you plug into your calculator to find the final volume.